This will be a detailed review for your LO2 test coming up next week. If you look in your Blackboard Learn course on the left-hand side, find the Review for Test 1A, that's your Learning Outcome 2 test. Then click on the link for the review assignment, Review Test CLO2. I advise you to try this by yourself first, and then only after, or if you get stuck, watch this video where I review all of the questions. Okay, the first question is talking about the difference between independent and dependent variables. And remember, independent variable is the x variable. It's the variable that comes first. And then the dependent variable is the y variable, and it's the variable that gets affected by the independent variable x, which came first. Okay, it's helpful to arrange the pairs of variables in this table as either independent or dependent. Let's look at the first one. The number of ice creams sold and the temperature outside. So the question is, which comes first and affects the other? I think the temperature will affect how much ice cream is sold. Okay. Let's look at the next one. The maintenance cost and the age. I think the age comes first, and that affects the maintenance cost. Okay, let's look at the next one. The distance you live from Pizza Hut and the delivery time. I think the distance comes first, and dependent upon how far you live, what the distance is, that will affect the time it takes for the delivery man to deliver the pizza. And then lastly, sales, I guess, of some item, and the advertising expensive. I think that first you do your advertising, and that has an effect on your sales. So in this question, it's saying which ones are dependent. Sometimes it will ask which ones are independent. This time it said dependent. So in this case, the ice cream is the dependent, the maintenance cost is dependent, the delivery time is dependent, and the sales are dependent. Okay, question number 2 is talking about scatter plots. Scatter plots are these diagrams where we see a bunch of dots, and they represent either one person or one item, and both the x and the y data associated with those items. And the hope is that when you look at the scatter plot, you see a pattern. It's also asking about the correlation coefficient. The correlation coefficient is represented by the letter R, and R will always be a number that is in between -1 and 1. It tells us if the relationship is strong or weak, and positive or negative. And remember, a strong relationship means the dots are close to a line. It's easy to see a pattern. And a weak relationship means the dots are very far away from the line. No relationship just means even the dots are all over the place. Okay, and remember, a positive or negative relationship is talking about which direction the pattern of the dots are going. So remember, a positive relationship is going up from left to right. That means as x goes up, y goes up. And a negative relationship is going down from left to right. That means as x goes up, y goes down. They're moving in different directions. So just as a reminder, this letter R will tell us whether the relationship is strong or weak. Close to 1 or close to -1, that's strong. Closer to 0 is very weak. And then positive or negative, if R is negative, it's a negative linear relationship. If R is positive, it's a positive linear relationship. So now the question is asking us, we want to know which one is closest to 1. That's a positive 1. So firstly, it means the dot should be going up from left to right. So we know it's not this one and it's not this one. And then we want it closest to 1. So we want it strongest. That would be this graph. This is very strong, which is figure 4. That represents a very strong and positive linear relationship. Now, figure 1 is also a positive relationship. You see a pattern going up from left to right. It's just that the dots themselves are not quite as close to the line. Okay, this next topic is a little bit more of the same idea, same vocabulary. It's talking about what positive and negative correlations, what those words mean. So before I even look at these statements, I'm just going to write down what I already know. In a positive correlation, the graph of the scatter plot will be increasing from left to right, which means as x increases, y increases, or you could also say as x decreases, y decreases. The point is they're both moving in the same direction. And in a negative correlation, the graph is decreasing. The scatter plot pattern is decreasing from left to right. So it might look like this, which means as x goes up, y goes down, or you could think of it as x goes down, y goes up. The variables will be moving in opposite directions for a negative correlation. Okay, so now we can look at the question. We need to choose 3 of these sentences are correct, which means 2 are not. A positive correlation means if one variable decreases, the other decreases. Yes, that is the case. They will be moving in the same direction for a positive correlation. A negative correlation means that there is no relationship between the 2 variables. That is not true. If it says the word correlation, there is some relationship. Okay, a negative correlation means that if one variable increases, the other decreases. Again, that is completely true. That's the second case where you have x going up and y going down, or x going down and y going up. A negative correlation means that if one variable decreases, the other decreases. That's not true. They're actually in that sentence describing a positive correlation where the variables move in the same direction. So I hope the last one is true. Let's see. A positive correlation means if one increases, the other increases. Yes, that means they're moving in the same direction. Okay, this next question, I can see a lot of sentences. So we have to choose which ones are correct. I see r and r squared. So before we even look at these, let's review what we know. The correlation coefficient is what we call the letter r, and r will always take on values that are between 1 and -1. And it also tells you if the relationship between x and y is strong or weak, positive or negative. Okay, now in this question, there's not too many things that talk about r squared, but let's also talk about it before we look to the sentences. R squared is the coefficient of determination. So just remember, the word correlation goes with r. The word determination goes with r squared. And whenever you square something, it can no longer be negative, so our r squared values will always be between 0 and 1. They'll always be positive. And because it's a number between 0 and 1, it'll be a decimal, which can be rewritten as a percentage. And so I want you to remember that the coefficient of determination is always a percentage, and it always tells you the percent of change in y, which can be explained by x. Okay, now let's look at these sentences now that we've written down everything we know. R can take values between -1 and 1. That's true. If r is between 0 and 1, there is a negative correlation. That's false. If r is between 0 and 1, that's a positive number, so it's a positive correlation. Next sentence. If r equals -1 or +1, then all the points in the diagram are on a straight line. That's true. That's actually called a perfect linear relationship. That's when the dots make a perfect straight line. A value close to -1 indicates there's a very weak relationship. That's not true. If it's close to either -1 or +1, that means it's a very strong relationship. Weak is when it's close to 0. R values are always positive. Well, again, that's not true. We can see that our R values can be anything between -1 and 1. A value of R that's close to 0 means there's very little relationship. I agree. Little to no relationship when the R value is close to 0. If R is between -1 and 0, there's no linear correlation. That's false. If it's between -1 and 0, it means R is negative, which means there's a negative relationship. If R equals -1 or 1, there's a perfect correlation. That is true. That's what a perfect correlation means. It means the dots are in a perfect straight line. R squared can take values between -1 and 1. No, we've just talked about how R squared has to be between 0 and 1. It has to be positive, or it could be 0. If R equals -1, then there's no relationship between the variables. Again, that's false. There is a very strong, in fact, a perfect negative linear relationship in that case. Okay, so for this next question, the first thing I think when I see a table is I'm going to need to use my calculator. So I'm going to write the calculator steps whenever we're doing problems in LO2. The first thing you're always going to do when you see a table is make sure you know which variables are independent, which are dependent. I think age of a tree will affect the height. So then I have to enter this table of data values in my calculator. I do that by pressing mode 3.2 in my calculator. I enter all the X data and then all the Y data. There will be a frequency column, don't worry about it. It will just fill in automatically. And then I press AC once I've finished. So question A is asking about the correlation coefficient. In order to find that, you press Shift 153, and we get that R equals 0.99. So part B is asking us to describe the relationship. There is a blank correlation between the age of the trees and their height. Well, the correlation coefficient is very close to +1. So we would say there is a very strong positive correlation between the age of the trees and their heights. So what that means, of course, is as the age increases, as the trees get older, we will expect the height to also increase. Part C is asking about the coefficient of determination, which, as you remember, is R squared. So to find it, all we have to do is take R and then square it. It's better if you just press the answer button in your calculator. That way we won't make any rounding errors. And then we will get a number rounded to 2 decimal places is 0.98. And what that 0.98 really means is that 98% of what we see as the change in the height of the tree is explained. It can be explained by the age of the tree. Okay, the next question is asking about the coefficient of non-determination, which, as you remember, is 1 minus R squared, which in this case would be 1 minus the coefficient of determination, 1 minus 0.98, which is 0.02, which means that 2% of the height of the tree is not explained by the age. Maybe other things affected the height, like was there enough rain or was there enough sun? So most of the height of the tree, 98%, can be explained by the age, but 2% cannot. Okay, question number 6 is a little bit different. It gives us the graph of a scatter plot and the line of best fit, and it gives us the equation and the R squared term, which, if you remember, is called the coefficient of determination. And remember, in the equation of any line, the number that is in front of the x is called the slope, and the number that is alone, not next to the x, is called the y-intercept. Okay, and just another reminder is R squared is called the coefficient of determination, and that represents the percentage of y which can be explained by x. So that means in this case, 82.72% of the change in temperature can be explained by the amount of rainfall. So now part A is asking about the correlation coefficient R. That's going to equal plus or minus the square root of R squared. We have to decide at the end whether to make it plus or minus. So that's plus or minus the square root of 0.8272. So we get an answer of either plus or minus 0.9095. Now the question is it going to be plus or minus? Remember, R tells you strong or weak, positive or negative correlation. So is this picture showing me a positive or a negative relationship? Since it's a negative relationship, we will make this a negative 0.9095. This is a very strong negative linear relationship. Part B is asking about the percentage which is explained. So they're actually asking us about r squared, which we already know is 0.8272. How do we write that as a percentage? So 82.72% of the temperature is explained by the rainfall. Part C is asking about the slope, which we already talked about. It's the number in front of the x in the equation of the line of best fit. So the slope is minus 1.0045. And for the last one, D, we've already talked about the y-intercept again. The y-intercept, you look at the added or subtracted term that doesn't have an x in front of it in the equation of the line of best fit. And in this case, it's 14.785. Okay, this question has lots of parts, so we'll try to carefully go through one by one, but the first thing I notice is a table of values. Thankfully, the x and y are labeled, so we know what's the independent and what's the dependent. And I'll start by entering in my calculator these numbers. So again, remember, you press mode 3-2, you enter the data, and then you press AC. Okay, part A is asking for the regression equation, which is the equation, according to your calculator, the equation is y equals a plus bx. So to find the a, you will press shift 151, and we will get an a value of negative 1.09. Then for the b value, we'll press shift 152, and we'll get a b value of 1.23. So if we replace those values into the equation y equals a plus bx, we get y equals minus 1.09 plus 1.23x. For me though, I prefer when the x term is listed first, so I'm going to switch them around and write them with the x term first. So the regression equation is y equals 1.23x minus 1.09. Part B says predict the delivery time y when the distance is 0 miles. The x equals 0, so we'll just replace in the equation 0 for x and see what happens to y. Once we do that, we get that the delivery time is negative 1.09, which doesn't make a lot of sense because you can't deliver in negative amount of minutes. So actually, it's not a very reliable calculation, which makes sense because the data they gave us was not anywhere close to 0. So we can make more reliable predictions if we were predicting something close to the data that was given. Okay, the next question says the delivery time increases by how many minutes for every 1 mile increase in distance? This is a fancy way of asking you, what is the slope? Remember, slope is always saying, okay, how much does the y change for every time the x changes by 1? So they're asking us about the slope. And if you remember from the equation of the line of best fit, the slope is the number in front of the x. So it equals 1.23. So what that really means is that for each mile farther away that you live from the shop, the restaurant, we can predict it'll take 1.23 minutes more for the delivery to arrive. Every mile away that you live. Okay, D is saying if the distance is 12, predict the delivery time. They're saying is if x equals 12, predict y. So I'm going to replace x equal 12 into my equation, my regression equation, and see what happens to y. So I get that y in that case would be 13.67. So what that means is if I live 12 miles away from the restaurant, I can predict the delivery time will take about 13.67 minutes. Okay, part E is a similar question. It says now the distance you live is 20 miles. Then if you live 20 miles away, predict the delivery time. Again, I'll just take x equals 20, replace it in my equation of the line of best fit, the regression equation, and see what happens to y. So I plug that all in and I get that y equals 23.51, which means if I live 20 miles away from the restaurant, I can predict that it will take 23.51 minutes for the delivery to arrive. Ask, is that prediction reliable if I live 20 miles away? Now it turns out that the predictions that we get using the equation of the line of best fit, they're the most accurate or the most reliable if the data we're asking about is close to the given data in the original table of values. But in this case, if you look at 20, 20 is far away from the given data, so we would say that the prediction is not reliable. Okay, so now let's look at the very last part. It says if the predicted delivery time is 10 minutes, then we should try to guess how far or the distance in miles that you live to the restaurant. So in this case, we're going backwards. They're telling us the predicted delivery time, which is y, is 10. We need to go backwards and find x. So how do we do that? We first will take the regression equation, the equation of the line of best fit. We'll put a value of y equals 10, and then we have to do a little bit of algebra to solve for x. So when we're trying to solve for x, our first step is going to be to try to isolate it on the right, make it all alone on the right. So we will remove the minus 1.09 by adding it to both sides. So when we do that, it cancels on the right-hand side, and then the left-hand side becomes 11.09, and we set that equal to what's left on the right-hand side, which is 1.23x. Now the last step to try to isolate x, to figure out what x is we want to remove the 1.23 and just get x all alone. So since that's multiplication, we'll do the opposite, we'll divide. So we'll divide both sides by 1.23, and that will give us a predicted distance of 9.01 miles. So that means if it took 10 minutes for the delivery to arrive, I predict that the distance that I live from the restaurant must have been about 9 miles. Okay, finally we've made it to the very last question in the review. And again, it's talking about the correlation coefficient and then the percent of variation, which is just talking about the coefficient of determination. So let me just review that a little bit again. The correlation coefficient is the letter R. It's always between -1 and 1, and it tells you is the relationship strong or weak, and positive or negative. Okay, we also have the coefficient of determination, which is r squared. That's always between 0 and 1. So it can also be expressed as a percent, which is the percent of y, which is explained by x. And then lastly, we have the coefficient of non-determination, which is just the complement of the coefficient of determination. It's just 1 minus r squared. So that's also going to be between 0 and 1, and it's the percent of y, which is not explained by x. So now, after all that introduction, we can take a look at this problem. It says correlation coefficient r is 0.75. So this means there is a strong, maybe moderate or strong, positive linear relationship between x and y. So now, when it asks in part A, the percent of variation which is explained, they are asking about the coefficient of determination r squared. And remember, it's always a good idea to just, normally when you have an ugly decimal, just write your answer squared. In this case, it's pretty, so we can just write 0.75 squared. So we get a coefficient of determination equal to 0.5625. The question, though, asks for a percent. So we can switch that into a percent by moving the decimal place 2 places. And we get that 56.25% of the variation in y is explained by x. Okay, for the next part, they ask for what percentage is not explained. That's talking about the coefficient of non-determination, 1 minus x squared. Sorry, I meant to say 1 minus r squared. So we'll just plug it in, and we get 1 minus 0.5625 equals 0.4375. That is the coefficient of non-determination as a decimal, but again, the question asks for a percent, so we'll move the decimal place 2 places. And we will get that 43.75% of the variation or the change in y is not explained by x. Okay, that's it. So the last thing I want to say is please study. Don't just think watching this video is enough. I advise you to go in and take the practice test by yourself, see if you can do it. And then also you can find all the links to the self-checks for LO2, and you can work on all of those. So go into your BB Learn course, find this review for test 1A, and there you will also find all 4 of the practice quizzes or self-checks as another way to review. Okay, good luck everybody.